Hi girls, next we are going to see about the 8th chapter, heat and thermodynamics. And when you see heat and temperature, they are two different phenomena. Now we shall see about the introduction for this heat and temperature. So temperature and heat, they play a very important role in our everyday life. And so here the chapter which the branch of physics which deals with the phenomena of temperature and heat is called as thermodynamics, that is heat and thermodynamics. And so heat and temperature are two different but closely related parameters, and we are going to see the difference between heat and temperature now. So what is called heating? The process of energy transfer from higher temperature object to lower temperature object is called heating. So this flow of energy from higher temperature to lower temperature is otherwise called as heat. And so here we can see one example for meaning of work. And when you rub your hands against each other, the temperature of the hands increases. So in cold times we will rub our hand to get heat, and so the temperature hands increase. And when the hands are placed on the cheeks, the temperature of the cheek will increase. This is because the hands are at higher temperature than the cheeks. Here this is not chin, this refers only cheeks. And so here this is shown in this example, a person rubbing his hands and keeping the hands on the cheeks. So by doing work on the system, the temperature in the system will increase and sometimes may not. So the rubbing the hands is example for work, and because of this work the heat is, that is the temperature is increased. Sometimes it may also it may not increase. So like heat work is also, it is not the quantity, and through the work energy is transferred to the system. And so here the transfer of energy from one body to another body through the process of work, they need not be at different temperatures. So even when they are at equal temperature, there will be transfer of energy from one body to the another body, because they need not be at different temperatures. So far we have seen about heat. Now what is temperature? The temperature is a degree of hotness or coldness of the body. You mark that. So how far it is heated up or how far it is cooled, that is given by the phenomena temperature. And the SI unit of temperature is usually Kelvin, and we can also use the two different units, Celsius and Fahrenheit, that is degree Celsius and degree Fahrenheit. And there is one tabular column to convert the Celsius to Kelvin. That is just we are adding 273.15 to the Celsius to get Kelvin. Similarly from Celsius to Kelvin. And so there are different equations given for converting temperatures from one form to the another form. And so next we are going to see about the thermal properties of matter. And for that the two laws, Boyle's law and Charles' law, are very very important. And based on these two laws, an ideal gas law is formed. And so here what is Boyle's law? So here the gas is kept at constant temperature, the pressure is inversely proportional to volume, that is P inversely proportional to volume, and here the temperature is kept constant, and this is known as Boyle's law. And what is Charles' law? Here the gas is kept at constant pressure, the volume is directly proportional to absolute temperature, that is V is proportional to T. So this is called Charles' law. So P inversely proportional to volume is called Boyle's law, and V directly proportional to temperature is called Charles' law. And we are combining these two laws, we will get another equation where PV is equal to CT and C is a constant. And we can show that the C is directly proportional to the number of particles in the gas container by considering one argument. And here we are having two containers. Two containers have the same type of gas, same volume, same pressure, everything is same. So this obey the above equation, that is PV is equal to CT. And when you combine these two containers to a single system, then the volume will be twice, also the number of particles will also be doubled, but whereas the pressure and volume will remain constant. And this is shown in this diagram. And first there are two individual systems, then they are combined together. whereas the pressure and temperature will remain constant, whereas the volume and number of particles will be increased twice. This is the example for this one. And so here you can say now P into 2V by T is equal to 2C. So volume becomes twice and constant is also twice. So here it implies that C must depend on the number of particles in the gas, and so also we have the dimension of PV by T is equal to joule K power minus 1, because for energy PV is given by joule and temperature Kelvin, so Jk power minus 1. So we can, from this also you can say that the constant K is K times the number of particles N, and where K is called as Boltzmann constant, and this is a given value 1.381 into 10 power minus 23 Jk power minus 1. So the ideal gas equation can be written as PV is equal to NKT. Instead of C, you can substitute Nk, where N is number of particles and K is Boltzmann constant. And so here, suppose there are mu mole of particles, then the total number of particles can be written as N into mu Na, where Na is called Avogadro number. Usually you have studied this in chemistry, where Avogadro number is 6.023 into 10 power 23 per mole. So now PV becomes mu NaKT, because NaK can be also written as universal gas constant, and its value is 8.314 joule per mole Kelvin. So PV can be now written as PV is equal to mu RT, because you have replaced NaK by R, where R is a universal gas constant, and it is given the value. So this is called a gas equation. So it relates pressure, volume and temperature of the dynamic system in equilibrium. So this is about Boyle's law, Charles' law and the ideal gas law.